Imagine that you want to cross-compile your Qt application on any host environment, regardless of type, like on Windows, on Linux, and you want to keep this build environment stable, and you want to distribute it in somewhere else. We see that this is possible with the Docker and Kemu in the previous tutorial. If you haven't watched yet, before starting this, I really recommend you to watch the first one, then you can come here, because we are going to use the container we created in the previous one. And in this content, basically we check some best practices using the container that we created in the previous tutorial, in the first tutorial. And using VScode, we will see that how we can debug the binary, remote debug the cross-compiled binary, which is cross-compiled in the container remotely on Raspberry Pi. We will make the whole process automatically handled by the VScode tasks, VScode the infrastructure. So let's start. In the first tutorial, I forgot to tell that you don't need to create the huge image which has the whole the Qt binaries, the sysroot, the toolchain. You don't need to create this whole image to build your real application, because it can take time. Even if you haven't touched the other parts of a Docker file, there can be the change in the Linux, which is the update can be needed. So even if you haven't touched yet somewhere, the Docker can check there's something to to be updated, and it can start to update the Linux part. Then automatically it will start to build image quite from scratch. This is not logical because it will take time. So you want to build your application. This is not correct. I forgot to tell this actually. That's why the first, as a best practice, one of the best practices, but there can be many ways to do that still. We are going to create another Docker file to build your application. This Docker file, we are going to create a container. This container inherits the big one, the big container. The container which has the Qt binaries that we create. Let's check here. That we created this one, the Qt cross build. We created in the previous tutorial 3 weeks ago. I don't know when. So we are going to create a Docker file, new Docker file, which uses this image, this container. So when you if you check out the repository, you can find all steps. By the way, below the video there's a link. So you don't need to do anything now to understand the situation here. Just check out the repository, and there are the files here. You don't need to do anything that I'm going to explain. Then you can change it later according to your needs, or you can do whatever you like. There is a new Docker file app here. If you check the content of this one, Docker file app, it is going to use the Qt cross build image, the container that we created before. So then it will copy the project that you have from this path. The path is not correct here. You should update it according to your needs. So for example, I am now in home/Qt on Raspberry Pi, so I need to update here. This is not correct right now. We can put some comment here also too. So then this will compile the application. The application is here under the project directory, which is here now. You don't need to do anything. This is just a simple hello world application. Then it will copy the binary here outside of after building it, somewhere here. Okay, to this path where you the same path where you check out the repository simply. So let's try to do that. But of course I need to update the Docker file first. Let's do that together. So you need to do that again also. Docker file app. Change this path where you check out the repository. Maybe you can create another. Yeah, it's a good idea to create another variable here, but yeah, whatever. Because otherwise it cannot find the application itself. Maybe we can create another variable, project path or repo path or something. Another one. We have the directory name. We are going to change it later to compile the QML application. So if you check here carefully, so this will just remove the directory if it's X or not. If it is, this is the first time, it's okay. But next time it will delete the directory. It's good. So it will create in the container the same path that you entered here, which is in the host, same path, and with the same project directory file. This is needed because we are going to build the debug application now, debug binary, right? We compile our application in a debug, in a debug mode. So that means the path information where you compile this binary, it is embedded in the binary. So if you check the binary in somehow with one of the tool, because of it's compiled in the debug mode, you can see that it is compiled under this path. So because this is important, because we need to have this binary to debug in the host environment. So we are going to copy this, right, somewhere here in the host environment. So when we try to debug it in the next, if you don't put the same path here with your host machine, then it will fail. The debug will not work correctly. So what I'm trying to say is simply keep the paths are same in your host and in the container. This is quite tricky. Yeah, this is kind of a workaround, but it is, you can change it in somehow. There could be many ways, but this is one of the simple way right now. So just keep put the same name, give the same name where you check out the repository. Just give the same name in the container. That is it. Then the debug will work as here now as I did with you. So let's leave it here. So I've created some, the image and the container later. Docker build -f, the file name, we are going to use a Docker file app, and -t like a final app dot. So this will create, as you see, it is compiling now. It created the hello Qt. There is no binary now. So if it created the hello Qt CrossCompiled binary, and now we need to create a container, to use this. So simply create name temp app, let's say, from final app. It created -a. We can check like this. So 5 seconds ago, the temp app is created, which has the application that we created, right? So we can copy the temp app. What was the name? It is under build project hello qt6. We can copy it directly here to check. Yes, successfully copy it. This is quite huge because it's compiled it's just a simple hello world application, but it is compiled as a debug. So that's why debug binary. There are a bunch of information in the binary. That is why it is huge. So if you check here hello qt, so you will see that it is exist here. So this is compiled for ARM, which is good. So what we did here, we have another Docker file app, and which uses Docker file app, which uses the Qt cross build container that we created before. So we don't need to create this again and again. Here, this inherits this line inherits everything from this container. You don't need to create this container again, because it will be it will take your time. It's not logical. So now we have another small container, not a small, but small Docker file app, let's say Docker file, and which is used only to build our application. This is good. You don't need to run. You don't need to build this Qt cross build again and again. So what we did before, we created another Docker file app, right, to create our application. Now we have hello world application here, but we don't want to do this by hand. Every time we don't want to write these commands, right? We can put somewhere these commands like a script to make it, to automatic everything. So if you check here the helper task as a script, which will be used later by the VScode that I'm going to show you, you will see that helper task. Let's check the content. You will see that there are some, the cases we needed in the following minutes. You will see. So this script, for example, here, the create build image build Docker image, for example. This script, if you send this command here, it will create the image and the container from it. If you give this command again, look, for example. So what I'm trying to say is here, for example, okay, let's check. For example, helper, let's check again. So I'm going to copy this. It is already done, I think. Helper bash helper task. So it's already created, right? We did before. Or create binary and copy. I just gave this name, but you can change the names. I just want to show you that we can put these commands in a script. So it is already exists. These commands are needed for the VS Code. So before start here, so you need to change again here these paths. You need to adjust these lines according to your, your need. You need to give, this script will connect to Raspberry Pi. So you need to give the username for your target for your Raspberry Pi, IP address. Be sure that this is your Raspberry Pi is pingable. And you need to give the path for the Raspberry Pi where you copy the binary. Okay. So this is not correct. This is home. No, it is correct because it will be copied here. So send binary to Raspberry. As you see that here, this Hello Qt 6 application will be copied. This path. This path later will be used by the GDB server. So we are going to run the GDB server on Raspberry Pi using the commands that I'm going to explain on the path. So the path should be exist on a target. Otherwise, you will see problems. This is the password for Raspberry Pi, and this is the path, on the target where the Qt is extracted, because we need to extract. We need to export the LD library path somewhere here. See here. Otherwise, the libraries, cannot be found, and the binary will not start. Debugging will not start. So you can check this. That we are going to talk a little bit more, but be careful. The IP address should be correct. The path should be correct. It should be exist somewhere in your Raspberry Pi, and the password should be correct. Before, you need to install on the targets the GDB server on the Raspberry Pi, and on the host you need to install SSH pass and the GDB multi-architecture, multi-arc, because we are going to the debug cross debugging. We cannot do that with the GDB. You need these things. So I installed already before. So I have already. So these are the versions. Also on the Raspberry Pi that we can check quickly that I can ping or not. So I'm able to ping my Raspberry Pi. I assume that you have VS Code here. So I'm not going to show you how to install VS Code now. What you should do to work, this to test these examples here to debugging right now without touching anything, you just need to update the variables, the path, password. That is it. The other also the correctly other paths. So just run the code here, the VS Code, in this directory where the checkout, where the pull. Simply the clone the repository. When you open a VS Code under this directory, you can see directly the directories here for the project, and there is one .vscode directory. This is important because there are tasks.json and it launches JSON files. These files are necessary for debugging and to use the script that I showed you. If you open this script, helper task script here, helper tasks, as you know, we updated here. I should update this one too. We update the path, the names here, So this will be used. This will be used by tasks.json file here. If you check this is the JSON file, the JSON format. You have to write like this, otherwise it will not work. So what we did before, using the helper task sh script, we send a command to this script to build our image, like a build Docker image, right? So if you check here, it is using the same command. So if you run the build with Docker task in the VS Code, it will call this command and the script will build the image for us. And it will, if you run this one, it will create the binary and copy the binary. And if you run this task, it will send the binary to the Raspberry Pi. As long as the IP address is available and the password is correct. Using, the SSH pass tool, we will send the binary. No, we will use a SCP to send the binary here. Sorry, still SSH, yes. So to run this script, to run these commands, also we are going to run the GDB server on Raspberry Pi. But be careful that you should install the GDB server on Raspberry Pi. How? You simply just go to your Raspberry Pi. So sudo install GDB server. I have it already with this version 13.1. So you should install it, otherwise it will not work, right? Because this script is not checking this GDB server is installed or not correctly. You can do that also. You can check before running this script it is installed or not, and if it's not, you can install, but I didn't want to do that. So it's up to you. You can change that. There could be many ways to do that. You can change also, you can remove this case structure, put something else there also. It's perfectly fine. My intention is to show you how to use the idea, you know, what is the theory behind this. So we have a task.json file and the script. Script is a interface, you know, is a between. It stands between you and the VScode. So if you click the Ctrl+Shift+P, then you will see this prompt. And if you click the run task here, it will give you the name of the possible tasks which is introduced in the tasks.json file. For example, you can build with the Docker. If you click this, it will build that we created before, right? Via the command line, but we don't need anymore. So let's try something else. Copy binary from temp container. It's creating, see, the container and successfully copied the Hello Qt 6 application. And also we can run, for example, the GDB server on Raspberry Pi. And also we can send the binary to Raspberry Pi, for example. Let's send it. So we can check that on the Raspberry Pi this binary exists. It's here. Okay, we send it already. We will also start the GDB server on Raspberry Pi, right? To debug it, we need a launch JSON. So this is just an options. There is a version and the configuration. This is still in JSON format. So what you should do that here for you, it's important. So you need to update again this path, everything here. This should be same, you know, in the script. Or I'm not sure that we can put here like a variable. So that is why we need to update by hand. You need to give the IP address of the Raspberry Pi and the port. So if you check the helper tasks here, you can, if you like, you can update. This script is created, you know, the GDB server is starting the GDB server in this port, localhost, the IP address of the Raspberry Pi and the port number. You can change it here. If you change this one, you need to change also in the launch JSON. This both should match. That's the point. That's what I'm just trying to say. So as you see that this is all just variables. The paths are important. Be careful, otherwise it will take time to find out the problem. So be careful of the paths. Just update accordingly. Where you just check out, just the clone the repository that we are working on now. So after this, as you see, I gave the name remote debug on Raspberry Pi. This name will be shown if you click this run debug part. It will be available here. Run debug on Raspberry Pi. This is the type CCPD. The types are just the name here. When you, for example here, you can see the possible options. That there is only one for me now. Which is the request is a launch, means there can be, you know, we are going to start the application, but also we can attach to application. So in this case, we are going to start the application. That means it is launch the application, not an attaching. Also, you can attach to application, the running application. This is the program, the path of the program this path will be on the Hello Qt, but be sure that this is the path where binary exists on host, not the target. Be careful here, because for the debugging, the copy of the binary should exist on the host too. This is the point. So stop entry is a false, just an option, and this is the host path again. This is just I put here. I saw on the internet actually that you can change the play with the options here. The mod is GDB, the IP address, and the IP address is here with the port number for the targets. And this is the GDB multi-arc. You know, you should give the path correct. But probably it will be same with you. You can check it. You should give the correct name of the binary of the GDB multi-arc. You know, otherwise you cannot use a normal GDB because we will make a cross debugging. These are enable printing. This is some just bunch of other configuration. This is I make it empty, but as you see that you can put your task here too. For example, you can kill the GDB server after finishing, you know, the debugging, for example, or you can start something before the launching the application. It's up to you. Again, as I said, to see this debug button here, you need some extensions. Probably you will have it, but if you install this VScode before, you need this not 3.1, I think. I have this extensions now for debugging and code browsing. And I also installed the, the extension pack. It's up to you. But you need these 3 extensions: C++, IntelliSense, debugging, and code browsing, whatever, and the extension pack of it. Then you will have this debug button. Otherwise, it will not appear here. So let's try to debug now. First, we are going to debug the Hello World application. Okay. So open the main CPP under the project directory, which we compiled, right, with the Control P here with the task. Now you can put, if you like, you can put a breakpoint, like for example here. And of course, okay, we can. It is up to use the steps, but just go to run and debug part. We need to start first with the task script that that I showed you. We need to start the run GDB server. We need to start the GDB server on Raspberry Pi. We already sent the binary. I'm not going to do that again. So I'm going to start the GDB server on the Raspberry Pi now. So you see that is here. It's started already on this port 2000. That you can find the port number on the JSON and the script. The process is started. The PID is this one. It's good. It's running now. It's waiting for the debug. So when you click this one, start debugging, be sure that you put the breakpoint, otherwise it will not stop. Just click the green one. It will give you some buttons to debug. Then of course this can take time, so it's connected now. It is the reading and all the symbols. So as you see that I didn't send anything. I didn't touch the sysroot. I didn't do anything more because it's a simple Hello World application also. That is why. But if you want to debug the sysroot libraries, like a touch screen library, I don't know, like this kind of which can be found in the sysroot, then you need to also give the sysroot path. That we can check this later in another tutorial, like a more advanced one. So it's working now. We are debugging the remote debugging our application, which is running on the Raspberry Pi. The binary which is compiled in the container in the isolated environment, which is quite nice. Actually, it's very cool. So we can we can change, for example, this is variable 3 now, right? We can say, for example, we can change the parameters here. See, it's debugging, and we can here. This is the buttons that I was talking about. So if you click, for example, step over, so it will go to the next line. So it will be 13, right? So yeah, we are just playing. It's good. Go one more line, and it should print. Where is it? In terminal? Yeah, in the terminal. It prints the outputs. And if you click again, it will end. So now debugging is finished for this simple Hello World application. So let's go to again here. There is a project and the project QML. You don't need to change anything. This is already ready to use. They are just a simple example. Open the main CPP here. So let's put something here like breakpoints. Here just 2. And there is my object header file here. There is also implementation. There's a function. Put here one breakpoint. We will click the button from the QML, and it will, this function will be called, and we will see the breakpoint here. Of course, now this is not working, as you see, because we haven't compiled this binary yet, right? So what we should do now, we should go to helper task project QML, because we are going to change the directory, right? That is why I created this variable, and go to the tasks JSON. We don't need here, I think. We need to go to Dockerfile app, of course, not here. And the Dockerfile app, put here QML, project QML. So I'm going to cross-compile another project. That is why I'm trying to change the path. So that is it. So keep it in your mind. Don't cross-compile the wrong application, then it will be weird. So in the Dockerfile app, I changed the project QML, and in the helper task, I change it as a project QML here. That is it. Now what I'm going to do, execute all the tasks here, right? So build with Docker. It will now build the QML application. It's a project QML with the same name. I gave the same name for the binary, but it's up to you. As I told you, it takes time. So it is successfully created. So run task, send binary. No, first we need to copy. You can also create one single task for all, or it's up to you again. Copy binary from the temp container. So the hello Qt6 is copied and we can send it to the Raspberry Pi. Yeah, this didn't work because probably the GDB server is running. So you should kill, or let's do by hand now. Kill all GDB server. Okay, let's do it again. Send binary to Raspberry Pi. Okay, it worked. GDB server, I think I forget to kill the GDB server, I think, on the target. So you should check this if GDB server is running, so you cannot debug the next one. And copy binary, then we can run now GDB server. Okay, it's running with this name of the application and the same port. So let's go back to main CPP. Now we are debugging QML application, right? Still, as you see that now the Raspberry Pi is running on my desktop here, but I'm not going to show you anything now. All the window will be shown on our host environment. This is the funny part. So what we did before, just click this button and run the debug. Yes, yeah, as you see that we forgot to run it, if we forgot to stop it. So now, as you see here, the breakpoints are red. That means they are available. That's good. This can take some time because there are now a lot of libraries to import. So there's a debug console. Do I need to run again? No, yeah. So now it stopped here. We can continue. It stopped here, and we can use this one. Continue F5, and it will jump here. So I expect to see the window here, actually, but yeah, that is why this is loading in here. So this can take time. It is still running the task. So we can check debug console here. Maybe it is loading something. Those symbols are already loaded. It's good. Let's wait. Yes, we have window. Now this window is running. Actually, binary is running on Raspberry Pi now. So CrossCompiled Qt6 on Raspberry Pi. There's a button. If you click this button, this function will be called. Right? I just bind it in the QML. You can check it. Simple. So let's see if it will work or not. So click the button, and there's a breakpoint here. Now this is normal because now we stopped the application. It needs send back the notification that this function is clicked. After some time, you see that the breakpoint, it stops. The application stops exactly where we put the breakpoint. So we are able to debug the QML application with VScode, and without touching anything, any container anymore. This is just with the script we can make we can make the process automatic, and it's simple. So you can also check the other. I don't want to touch this. It will take time now. But also you can play with the variables here. So this is normal. Just don't touch anything and just click the F5 again. Then this will come back. You can test this again. As you see that it is working very well. It's good. So let's stop debugging now correctly. I think that in the previous Hello Qt6 for Hello World application, I didn't stop the debugging correctly. So to stop debugging, just click here, stop. Also the button clicked, see the debug is printed here. The couts are printed here. That you can also debug your application. You can print something here. This is still working. Yes, thread 1. Or you can also kill it here. Okay, it's killed also. But this should stop. I don't know why it didn't stop. Maybe I should wait a little bit more. But it is working. So it is okay. So guys, that is it for me here. What we did in this content, we checked that how we can debug the application with the VS Code, and how we can make the compilation process automatic with the scripts, with the tasks, with the VS Code. There are ways to call the script or commands with the task JSON. So, but be careful. Just try this using the repository that you can find the link below the video. Otherwise, when you start the VS Code, if it does not find this directory .vscode, and it will ask you to create this, so you can do it later if you have another project. So you can copy paste these files to as a reference point, let's say. So if you have any question, please let me know. If you like the video, like it, share it, and don't forget to subscribe. Enjoy.